Yeah, let's jump straight in if that's okay with everyone. Hey everyone, welcome, and I hope you don't mind. I'm going to be reading some remarks. I have a few things that I don't want to forget. So thanks a million for joining, and yeah, just a reminder that the session will be recorded, and I'm going to promptly upload it onto YouTube, especially for those who weren't able to join live. So before we jump into the session, I just wanted to say that hopefully early next week I'll be able to confirm next month's AMA session and next month's virtual workshop. So stay tuned for that. But let's get into the main focus for today. So just to give a quick summary on the schedule for this session. So we'll start off with getting to know Alex a little bit, just through a few questions, and then followed by a product demo that Alex has kindly prepared, and we will also have time for a few questions at the very end. So feel free to add any questions that you might have during the session or as the session progresses. So to introduce the speaker, we're incredibly fortunate to have Alex Jones joining us today. Alex brings a wealth of experience as a software engineer and Kubernetes expert with extensive experience spanning various roles inside the tech industry, from senior positions at renowned companies like Sky and Microsoft to leadership roles in platform engineering and SRE positions at American Express, JP Morgan, Civo, and most recently director of Kubernetes at Canonical. So, and in addition to his professional accomplishments, Alex is an incredibly prolific contributor to open source software and a passionate enthusiast. He serves on the advisory boards of Ondat and Kepton, while also holding the position of tech lead of Tag App Delivery at the Cloud Native Computing Foundation. Impressive as all that may be, those are some of the many topics that Alex could impart knowledge on, but none of that really is what we're going to cover today, since we're very lucky for Alex to showcase his latest project, which is K8sGPT. How you find time to do all of that, Alex, I do not know, but it's great to have you here for you to tell us. So Alex, welcome. I hope I didn't miss anything, and just if you would feel free in your own words to tell us a little bit about yourself, and take it
Thank
away.
you. I think you've earned yourself the title of like my herald, with all that. It sounds more impressive on paper than it is. I mean, all of us over our career accumulate lots of little things we do, but when you compound it all together, it sounds like a big kind of like roll of accomplishments. So thank you. It was funny listening to memory lane there of things like Sivo and other companies. Yeah, I mean, I am like anybody who has been in the space for a long enough time. You accrue, various experiences, and I'm lucky that I've had some interesting ones. Largely working in Kubernetes for the past 5 or 6 years has given me some interesting opportunities and interactions. And I would advise to anybody who's interested in open source to contribute and to consider things like the CNCF as a good place to get started, because that broadly speaking is a wonderful platform for learning how to make friends there and to contribute to Kubernetes. But yes, thank you. My new project, and I'll go on to speak a bit more of this later, is today is to talk more about the AI side of things. And so hopefully we can eventually dig into that a bit more.
Yeah, for sure, and we definitely will. But before we do that, though, I just wanted to kind of like take a little step back and kind of think about Kubernetes as a whole, and I think you're in a good situation to give us your opinion about like what you think are currently, like specifically like now in the present and maybe in the very short term future, what are the kind of like pressing use cases and kind of like most kind of like critical issues that Kubernetes contributors and projects that are building on top of Kubernetes to expand its capabilities. What are those most interesting use cases being worked on at the moment, and what's going to be the most interesting places to work in the future?
It's a broad set of questions. I'll do my best to answer. I think firstly, it's important to understand Kubernetes has been commoditized, which effectively means that it is something you can pay money for and have a service. And that really represents one end of the spectrum where hyperscalers such as Google, AWS, etc., allow you to pay some money and you get the API. Kubernetes as an API was projected, forecasted by Kelsey Hightower a few years ago, and it's been true in that people don't really want to run their clusters, at least the majority of people don't. They just want to be able to use Kubernetes. And so we're seeing an influx of small companies as well trying to leverage that space and to get involved in how can they serve Kubernetes cheaply and quickly. But of course, on the other end of that spectrum, you then have larger organizations who may want to run their own. And so bare metal and virtualized Kubernetes and ways to pack it in new interesting ways is certainly an important and interesting focus. For example, with telcos, they're now trying to put Kubernetes in base stations. So when you have a phone, that signal on your phone, as you get close to that tower, it can start increasing the bandwidth on your phone. That has a Kubernetes cluster in many cases that's then scaling up pods inside a micro K8s or in a K3s or in some other small distribution. So the world is changing with a real rapidity. And in a sense, that kind of leads me on to the question of what are people focusing on. I think really what we've seen now is Kubernetes has become stable, right? And people are looking at extensibility. So whether that's identity, finding new ways to bring identity into Kubernetes, whether that's storage, finding new ways to access storage mediums, or whether that is something like network offload and acceleration, we're seeing that as well. Many years ago, I used to work for Microsoft in the games industry, games like Black and White, Fable, and a few others. And back then, network acceleration wasn't really something that was possible or even public. It was the purview of server rooms and data centers. But now you can buy an embedded card on a chip for less than $1,000, and that, when you combine it with K8s, gives you the ability to say these pods need to go super fast. They need to talk super quickly, and it now means that really complicated things like running a low latency crypto server or having some sort of mining operation or doing calculations. Yeah, so it was certainly the latter. I had led several SRE teams at Civo, JP Morgan, Amex, and the recurrent theme to me was that a lot of SRE practice is tribal, right? You do something and you remember it and you pass it on to someone else, like a tribe. And very little of it was codified and reproducible through CI/CD. And so I started building up a concept very early on of actually writing in Golang a way to detect a lot of the common, most plausible issues that you would find in a cluster. And with the emergence of LLM APIs, it seemed like a very unique opportunity to actually say, well, here are the issues. Let's actually simplify that. So even the most junior of SREs in a team had a good shot at actually remediating something. And so really, I think it was a timing thing around the kind of these public APIs, but also that I had a very, very applicable use case for them in infrastructure, which is fairly unique. I think that it's important to really contextualize the way that the market works, right? These hyperscalers have large tables, and these tables, they've got lots of dishes with different offerings, right? If you think about that analogy. And so if you go to their table and sit down, you can choose from any of these dishes and you can have combinations of rice and pasta and curry together, whatever, right? So you can get any flavor of service you want in that provider. However, a lot of companies, as part of their de-risking and strategy, are trying to move between clouds. So they want to sit at two tables at once. And that's a bit awkward, but you can do it. So really, what a lot of these smaller companies are doing to make money is that between these tables, they're picking up the crumbs, right? They're picking up the bits that aren't catered for, which is, for example, being able to have observability across GCP and AWS holistically is a really good moneymaker because neither of those two organizations would want to do that as a product, right? They wouldn't want to support either's platform. And equally with the Kubernetes debug and triaging tools, because you're not at the table, you don't have someone passing you the cutlery, you got to make your own, right? So really, when you see these companies that are offering debug and triaging tools, they're kind of thinking about people who want to use K8s wherever. They're not talking about specifically using it on GCP or AWS. For example, if I was doing an observability tool or a debugging tool in AWS, Amazon would come up with something better and be able to sell it cheaper and probably integrate it out of the box. So I think a lot of these platforms appeal to engineers who are a bit hesitant to just go all in with the technology, but also they're trying to leverage this idea that the complexity of Kubernetes is there's a value, a monetary value in decreasing complexity, and people will pay a small amount to be able to surface that decrease that complexity and surface detail. But it's a dangerous game they play because, as I say, you could take any one of these tools, which I won't mention, that can do like CVE scanning or debug analysis. If Amazon or one of these companies turns around tomorrow and builds a service out of it, you've effectively lost that battle on that platform. So it's a really interesting time, and I think there is a tipping point where these services can become big enough to become household names, like your Datadogs, like your Dynatraces, where they effectively become like a Switzerland, a neutral vendor that people will go to outside of these clouds. Yeah, I think when people started thinking about multi-cloud a few years ago, the way they envisaged it working was that you'd have some clusters in Kubernetes in GCP, some in AWS, and maybe a database even shared across those clouds. But the reality is that, there's so many difficulties from a technical perspective of doing that at such little benefit that actually a lot of the focus changed to the tooling. And so people effectively then said in organizations, we need to be sure that should we want to switch clouds, we're not locked in. And to do that, a lot of abstraction layers were written, one of which is cluster API within the Kubernetes project. If I have a cluster API definition for how to deploy a cluster, I can do it in GCP, AWS, DigitalOcean, et cetera, et cetera. And that then de-risks my lock-in because it's a generic interface. And to some extent, cloud providers are also playing along with this because they could potentially now win business that they might have not before, right? If someone says, oh, well, actually, GCP supports CAPI, we can then create clusters there. So there is a level of what I think is kind of a benevolent but yet commercial incentive here, in that by subscribing to common APIs like OpenTelemetry, etc., and cloud providers and even smaller cloud providers, it means that they are effectively winning the hearts and minds of people who are shopping for a home for their resources. And even though people have become more pragmatic at where they put resources and how long they live there, if you're part of that club, then you have more of a potential of being a cloud provider that offers no API to just deploy out a sort of a templated system like Cluster API. I think just also to close that thought out, we're seeing really that hybrid cloud and multi-cloud is the response to risk, right? You don't just go multi-cloud for no reason, and the risk is decreasing as the clouds increase their region coverage. So AWS is increasing as an example. It now has private regions as well. It also has more fragmentation, which means within a region you can now distribute higher amounts. I think there's a joke the other day about US East 1 going down. That's obviously critical for many people's business, and that's why people wanted to have a multi-cloud strategy. But really what cloud providers want to do is they want to remove that incentive to ever need leaving their cloud. Of course, yeah. I won't take too long. Let me just I just wanted to just share my screen, but I'll start with I'll start with the spiel, which is the kind of website that describes it, I think, in a better way than I could, in a very quick way. So K8sGPT is a tool that effectively lets you debug and triage issues in Kubernetes. It uses AI in the last 10% of the tool, right? Most of the tool is all Golang based. It's codified analyzers, right? This idea of like work hard, smart, not hard, means that run our Golang based analyzers, see what's going on, and use AI to simplify it. So this website, K8sGPT.ai, feel free to check it out. It's a completely free project. It's actually being incubated, well, actually trying to get it into the CNCF right now. If you're interested in contributing, checking it out, we've got our repository on GitHub, and it's been well received. The project was actually only started 3 months ago, and we're getting to about 3K stars with about 300 forks coming up. And the idea is that you can use it as a CLI. You can just run a quick check and say, hey, what's going on in my cluster? You can integrate it into your build tooling, or you can run it as an operator in the cluster continuously to see what's going on. So with that said, I think it's always much more fun to actually show you rather than just explain. So let me just switch over to sharing my CLI. So let's just change my window to my Zush. Okay, so I hope you can all see this. This is just a terminal on my computer. I have downstairs a rack of Kubernetes machines, and as you can see when I go control get nodes, I have a bunch of nodes downstairs. Now I've done a brew install of K8sGPT, And that then gives me K8sGPT locally. And what I want to show you is some of the capabilities. So first of all, when you use it, what you want to do is you want to log in to an AI backend. You don't have to, but you don't get the AI bit unless you log in. One of the things that was super on my mind when I thought about building this was that I don't want to just use OpenAI. I don't just want to use this, that, the other. So out of the box, it supports a bunch of different AIs. What's quite interesting is that it also gives you the ability to use something called local AI. If you have your own model, if you train your own model, K8sGPT can work off that model. So people who might be familiar with Hugging Face, the website and company that offer free models, means you can use like Llama, you can use GPT-4o, you can use BERT as well. And these are all different large language models. And effectively, K8sGPT has an API through local AI that lets you use the inference components of those. Sounds a bit like a rhyme. So you can see here I've basically logged into OpenAI. There's a whole login flow. You provide your token, and that's set as my default AI. I also then can say, well, K8sGPT filter list. What are the resources that I do and don't care about in my cluster? Here you can see I've got a bunch of the usual suspects, but also I've got a blue one because we have integrations with other tools like Trivi, Prometheus, etc., etc. So if I want to then go and do a quick analysis of my cluster, I can say, analyze JSON, JQ, because it's all built in this Unix philosophy that it should be reportable. If I don't want to do that fancy way, I can just say analyze, and I get the same detail, but it's a bit more readable. So you can see, which is super interesting, is that I have critical vulnerabilities found in Grafana, and I can see that I've actually got the Grafana, the vulnerability linked here. Right, which is something that's, I think, super useful when you're getting started, because you can say, okay, well, right, there's an issue. Now, still, at this point, we're not using AI. When we use AI is at this next phase, when we can say, well, analyze, explain, right? This is where it starts to look at your issues, it packages them up into a prompt payload, and then it will go ahead and try and figure out a way to explain this challenge or this issue in a much simpler way. So let's go ahead and create an issue in one of our clusters. So I'm going to go ahead and use a tool called K9s to find a pod in a cluster. So I've got a pod right here called Delta running in the bar namespace. So I'm going to go and I'm going to mess around with Delta. I'm going to change something in here to break it. Probably the easiest thing to break would be the memory request to set this to 1 meg, to set the limit to 1 meg. So effectively, this process won't start. So hopefully what we'll see in a moment is that when I run Delta, this new container creating will fail because it will go out of memory. And this is a really normal scenario. Sometimes people set limitations up on deployments arbitrarily. Sometimes you've got a JVM that maybe uses way more memory than you expect, etc. What you can see here is this is a really tricky error because it looks like it's creating. It's going to sit like that forever. But actually it's failed. Inside here, you can see it was killed out of memory by the container init process. And this wouldn't get picked up in a lot of detection methods. So if we go and use K8sGPT, we can analyze and we can do a quick analysis. And that analysis has now detected this. What I can also do is I can go ahead and get an explain on that. And the explain gives you a methodical approach to figuring out what's wrong. So if I look, failed to create because of this issue with starting the init. Is your memory limit too low? Right? Look for increasing the memory limit inside of the deployment. Describe the pod and find the limit. So you can see the night and day difference in the level of detail you're getting from just doing an analyze versus actually doing an explain. It actually gives you that extra level of prompting. And so it's my hope that this can now help people to start to feel a bit more empowered to fix things. But that's not all. K8sGPT is a CLI, right? But it's also an operator. You can go Helm, search, repo. I think it's Helms. Yeah, there's an operator that we have as well, and you can get that from the K8sGPT-AI/K8sGPT-operator GitHub repository. You install the Helm chart repository, and away you go. What this gives you is effectively an in-cluster operator that is continuously scanning. So if we go to our K8sGPT operator system, you can see I've got a Helm release this operator. Inside here, it's continuously checking to see issues. That's interesting because I can see it's talking about bar delta. If I go into my results, I can see that the deployment of bar delta has a new result. And again, if I go down here, I can see that solution has been published into the details of this. What's quite nice as well is that we've recently added inside of K8sGPT the ability to have Slack connection. So that what I'll show you very quickly if I change screen again is we have now a nice little Slack component that you can see. Hopefully you can see this, right? Where it's printed out that I've now got a new issue in this deployment. And it also gives me the solution directly into Slack. So the idea is that engineers are not having to be subject matter experts at Kubernetes to get up and running with this. And in a nutshell, that really is what K8sGPT is all about. It's about trying to accelerate productivity by giving people shortcuts and hints into how to do so. And so when I come back to my deployment here, I can see, okay, it's inside this namespace. I immediately know what to fix. And again, I can go down and either increase my memory or delete those requests straight away. So that effectively summarizes where we are. Just to conclude, if you're interested in trying it out, please do check out the website, k8sgpt.ai. Feel free to talk to our community. It's all open source, no company behind it. It's just a bunch of people from the CNCF and other contributors. And we really, really are keen to get feedback on how people are going to use it. Just as an insight, K8sGPT also has a backstage integration. If you're using Spotify's backstage, you can see your K8sGPT resources. And I'll just end on a final image, which I'll share with you from the website. If we go to k8sgpt.ai, you can look in our blog, you can find that we've actually got a really nice article that's been published by one of the Spotify engineers over here, where you're able to see in very small detail just there, a little article about how to use it with Backstage. So I hope that's been useful, and I'm welcome to any questions, and love to hear more from the community, really.
Yeah, very interesting. One thing that just came to mind there was, so you mentioned that sometimes it can be a bit difficult to that the resource requests and limits inside of a deployment can be off, and in the kind of like best case scenario, it just means that you might be using the underlying resources inefficiently, and you might be like paying a lot of money for something, for a pod that maybe wouldn't need it. But in the worst case scenario, the pod just never stands up. But and I know that K8sGPT is helping a lot in the moment of finding out when it does go wrong. But is there any way that that you see K8sGPT helping in the planning stage of the deployment? Because sometimes it's not intuitive for some people to know exactly what resource limits and requests are needed for a certain deployment. Would that be possible to address with some sort of tool similar to this?
Yeah, I think the reason I specifically didn't go into that area is because there are plenty of static analysis and configuration scanning tools, right? So whether that's Trivy or Kubescape or any of those tools that are already open source, they don't need AI to do this, right? They can just look at a YAML file and determine, you're missing this value. I think the benefit of K8sGPT, and I'll just share with you a little bit of the roadmap here, is that we're not just using LLM APIs. I'm actually training a task-orientated AI using Kubeflow to be far more accurate. So I've just said a lot there. I'll just unpack it. I'm training my own model that is based purely off Kubernetes data. Because when you're using an LLM API, that API also knows like postal codes in Nigeria. It knows the temperature of chocolate to cook, when you're doing a souffle, and adding a chocolate souffle. It has so much relevant data that not only are you sifting through that and paying for it, but also it's increasing the chance of hallucinations and inaccuracy. So the next generation of K8sGPT is going to be using our own custom model that we package through local AI. But then the future of this is that we can all start to make suggestions. So just like you were saying, we could say, oh, well, your application has used 300 megs of RAM. We suggest you set a limit at 350. And that's a runtime thing that can't really be done through static analysis. eventually K8sGPT will become the autopilot for Kubernetes. It will become the CNCF de facto way of driving K8s. That's my mission goal right now. So that you effectively don't have to hire an SRE. And if you do, the SRE is writing interesting things like observability tests and signal analysis. And I think it will shift the industry somewhat because there is a stagnation and a false idea around operators. Operators are thought of these things that control applications in a very clunky way. Really, an operator is a synthesis of human behavior, right? It should be what would Alex do if he was fixing this thing, if he saw this issue, and that's as intelligent as we need to get to with these task-orientated AI.
How interesting. Like, I mean, just off the top of my head, I'm thinking that those suggestions could even be tailor-made for certain scenarios, right? So you could say, hey, could you suggest a situation in which I'm 100% optimized for cost? Or, for example, 20% optimized for cost, but 80% optimized for resilience, for example, and then uh, potentially being able to kind of like tandem on different variations of architecture of your clusters to reach a certain goal. That would take a lot kind of time of kind of planning and a lot of meetings if you were to do it with your team of SREs, I
I think
suppose.
it's certainly something that I've been thinking about in our early experiments, and I'm working with another individual on the machine learning side. We're looking at using an additional vector database that lets you put it in front of the inference API to give additional context. So rather than just going to OpenAI with 5,000 tokens describing an error, what if you could actually take 500,000 tokens of context, right? So say, this is my cluster, it has this many nodes, there are 15 people that use it. The last 3 days, we've seen a few problems. Imagine how much more relevant the answers would be. And then also take that a step further and think about not using a remote LLM, but using your own model that's completely understands your business. So with regards to your costing question, it would know precisely what previous cost estimates have been and know how to tailor and to shape and then to relearn and to retrain from that.
Yeah, I mean it's because one of my questions that I was going to ask before, which you kind of already answered, was how do you kind of like handle those errors that a lot of us have seen when we used just ChatGPT. But of course, if you're training a specific model that at some stage is going to know pretty much all of the different ways your cluster can fail, and not only that, but it knows your environment also, it's going to be very, very difficult for it to make a big mistake or a hallucination that's really going to hurt you in a
Yeah,
way.
and I think if you think about what people are doing with ChatGPT right now, historically, like every company has some sort of little plugin that lets you generate boilerplate code. Like I don't really see how useful that is. Like, okay, give me an Nginx deployment. Okay, so it's giving you a really simple implementation. I still have to do a bunch of work to fix this, right? So the initial integrations I've seen with these LLMs is that people have done very low-hanging fruit that kind of look impressive that actually have a lack of substance. I want to go the other way. I'd rather do a few things and tailor them to get really, really well refined and be an expert at them. So, for example, as part of the training for K8sGPT, when somebody looks at one of these results and analysis, we're adding in an option eventually to say, yes, this solved the issue. No, it didn't. Because then what we can do is take the tokens from the response of the LLM and use those to weight the next set of inputs for the new model that is going to be trained. And by doing that, we're building more and more accurate feedback based on real people that are analyzing this for us. And that's effectively reinforcement learning.
Hmm. Is this something that you're like implementing inside of Canonical at the moment, or is this 100% a side project?
This is purely a side project. I mean, I do use MicroK8s, which is an awesome distribution to run Kubernetes on. But running Kubeflow as well, and then building a model is expensive business, and so I'm doing that asynchronously, just as part of this open source community. I think it's super important that there is high quality AI tooling in the CNCF. That's not just like a chat GPT clone or a bot that spits out templates. this has real world value. And as I say to everyone, it's only like 10% AI, right? We're just using AI to really improve the answers, and we're eventually going to increase the AI opportunities as we see fit, right? There's no point just throwing it into AI and saying, do something interesting. I think it has to very much be a very cautious and modest approach that brings real value.
Just wondering, and we can wrap it up unless there's any questions from the viewers. Is there anything that, and this is kind of like more broadly in regards to AI, are you worried about or cautious about the way AI is or should progress? Is there anything that you're going to personally trying to be careful about?
I think the real issue with the current generation of LLM API that you can pay for or use for free is that they've been trained on a very wide corpus of data, but also an outdated corpus of data. So you're getting information from about 2 years ago. So really, as the state of technology changes with some rapidity, you're going to see that a lot of the LLMs are giving you kind of clanky and out of date information. I think that the quality of data is going to come under a lot of scrutiny. I wouldn't be surprised if more EU legislation comes in for the full disclosure of data sources. And that will mean that local training becomes not just an option, but actually like an imperative for many companies. So yeah, I would say that if I'm honest, I think OpenAI has probably had its moment in the sun, right? It's revealed ChatGPT, it's ignited the world and showed how popular it was, but I don't really see them innovating on that product much more, right? Because they've trained the models off of proprietary data sets. They're going to have to start training from scratch now, and they've already given the head start to other companies who have seen that there's an appetite for it. For example, Google have gone all in with this just recently, but Apple haven't even started. And usually, Apple staying quiet on something means that they're probably really innovating and taking the time to build it correctly.
Yeah, and the fact that local, highly customized and highly specifically trained LLMs is kind of like taking the good part of AI and getting rid of the potential downsides, right? Because the potential downsides come with like general like and just kind of like increased and just 100% how to put it huge general AIs that just keep on compounding and potentially spinning off in ways that are not easily foreseen, whereas a highly specific localized LLM that understands Kubernetes 100% but not that much else, and understands your environment 100% but not really but it does know how to make a souffle, for example, is 100% desirable.
Yeah, I mean, really, an LLM is a finite state machine, right? It has a finite amount of outputs and a finite amount of inputs. Like there are, say, several billion parameters, which means you can give it lots of words, but there are only so many combinations of those words in those LLMs, and so you can methodically, with time, potentially wheedle out every single permutation of answer from an LLM because it's just a set of weights across different superparameter thresholds. That said, the inverse is also true. If you build one, as you say, with a very small parameter range and a very acute set of information, you can actually build something that effectively will always give you a correct answer for a correct input, right? So if it's deterministic, the output would also then always be deterministic if you turned off any sort of temperature or any sort of chaos. And I think that's really where it's more interesting, isn't it? Because you're compounding, it's effectively becoming crystallized organizational knowledge in a program.
Perfect, yeah, and super interesting. So, I know you're an incredibly busy guy, as we've seen at the top. I was just wondering, apart from collaborating on issues and communicating through GitHub, is there any other way that contributors could get in touch or collaborate? Is there a community going?
Of course. Of course, yeah, we actually have a community page which gives you all the information about our office hours. And I'll just link it in the chat. Oops, no, I linked the wrong thing. It gives you a information on our office hours, our Slack, And if you want to ask questions, please feel free to jump on in. As I said, it's a completely open source project. So, we also have an expectation that people who want to ask questions also might want to contribute something eventually as well. And if that's not your style, then there's also a docs page as well. So yeah, please check it out.
Perfect. So yeah, I'm sure people will. I know I will. Thanks a million for everything, for your time, Alex. Um,
Problem.
yeah, enjoy the the sunny weekend. I think in your area it's going to be pretty nice.
Hope
Uh,
so. Yeah, yeah. Thank you so much. It's been a pleasure to be on.
cool. So thanks a million. Catch you
Thank
next
you.
time. All the best.
Bye bye.
Right. Bye bye.